Well, greetings from the Math Cave. I've been asked to take a look at a few problems from here. There they are. So let's take a look at these and see if we can work them out. These are all integration by parts problems, and we'll start with the e to the x cosine 2x. See how that one works out. So we want to integrate e to the x cosine of 2x with respect to x. And so the first step is to identify u and dv. And honestly, it doesn't matter in this one what you do. And so you can pick either one. But knowing that it'll be easier in the long run, I'm gonna use u equals 2x. Cosine of 2x. And then dv is equal to e to the x dx. Let's go ahead and work this through. Du is equal to 2 sine x, sine of 2x, that's a negative. And v is e to the x. Let's plug these in, and you get this, that the integral of e to the x cosine of 2x dx is equal to, let's see, it's going to be uv minus v du. So this will be cosine of 2x e to the x minus of v times du. Oops. So far, so good. Well, at this stage, we are at the point where we would either give up, because this is still not something I can, although I guess integration by parts is an elementary method. But so you can either integrate this, give up, or let's just go ahead and do integration by parts a second time. Let me just make these both positive, though, make things easier on myself. Now, if you're going to use integration by parts more than once on a problem, always use the same u and v. That is, so since u up here was cosine, it's going to be this sine now. So u is equal to 2 sine 2x. And dv, we're going to use the exact same dv. So 4 cosine of 2x, and v is e to the x. Okay, so hopefully that makes sense. Now let's go ahead and plug this into this one. So all of this stuff goes in here. So let's see. Okay, so we have uv v du. Let me just rewrite this one more time. Factor out e to the x. And notice what you've got here. What we have here after doing integration by parts twice is we're back where we started from. Now, a lesser mathematician might give up at this stage, but you aren't a lesser mathematician. You can do this. Just think of this as an algebra problem now. You have this thing right here, which is the same as this thing. Notice that I've kept this through the entire problem here, just to sort of make sure that it stays where it belongs. Anyway, I've got one of them over here. I've got 4 of them over here. That means that 5 of them should equal this stuff that's left over. Well, you can do the algebra now. Just divide both sides by 5. Final answer. Cosine 2x, 2 sine 2x. E to the x all over 5. And, whoops, let's see, this is not working for me. There. And if you were, if you want to be correct, since this is an indefinite integral, don't forget plus c. All right, that took a while, but let's go on to the next one. Let's see, what else did you have for me? Okay, these are going to be easier. That one was special. Let's see what's next. Ooh, these are all good. Yeah, let's do that second one, the x over e to the x. Okay, so let's do that one. So here's the integral of x over e to the. And the way you're going to do this is you write it like this. And now it should be obvious what you're going to do. You let u equal x, dv is equal to e to the negative x dx. So du is equal to dx. Sorry about my handwriting. And v is negative e to the negative x. So this one's actually quite simple. uv, x, let's see, put the negative there, minus the integral of v du. So I've got another negative, double negative here. I'll just put it in. That's both positive. So it's negative x e to the negative x minus e to the negative x. This is something you can integrate yourself. All right, so that was easy. Onward. Number 3. Let's see, e to the 1 over t. Oh, you know, this is just straight substitution. Okay. Oops. Sorry. I don't know what it's doing now. There we go. So straight substitution, this is e to the 1 over t squared. We're integrating this with respect to t. So let's just let u equal 1 over t, negative 1 over t squared dt. So let's just, let me just rewrite this. 1 over t times 1 over t squared dt. Now it's pretty obvious here, hopefully, that there's your substitution for d, your substitution for u. So this ends up being the negative, because of that negative there, of the integral of e to the u du, which is just negative e to the u plus c, and negative plus c. Check it with Wolfram alpha. Last one. This thing keeps switching on me. Sorry. There we go. Okay, x cubed natural log of x. So let me write this down. All right. Okay, so really with integration by parts, you're going to want to practice it and see it done a number of times, because then you'll start recognizing when u is going to be your polynomial and when it's not the polynomial. So in this case, you don't want u to be the polynomial. Unlike if you're doing x cubed times sine of x, or x cubed times e to the x, any of those transcendental functions, those exponential or the trig functions, you would let u equal the polynomial part, the x cubed. But here, I want u to equal natural log of x. This is the same case when you're dealing with arctangent. And the reason for this is because when you do the derivative of natural log, you get rid of the transcendental function. You get rid of natural log and you just have 1 over x. So let's make dv the rest of this, which means v is equal to x to the 4th over 4. Oh. And let's plug this in. U times v is x to the fourth over 4 times natural log of x. The integral of v du and this is so easy, it's embarrassing for me to do it for you, but I'm going to. And then this is going to be x cubed. Oh, look, it's so easy and I mess it up. Okay, this is going to be x cubed over 4. When you integrate x cubed over 4, you get x to the fourth over 16. There we go. Wolfram Alpha, that one. Okay, bonus material. Since it's not listed, yeah, and I'm not going to do that differential equation that is here. I'm just too lazy to. So that's just the way it is. Yeah, that. But I'll tell you now that when you do that, you're just going to integrate both sides. So on the right side, when you integrate this, let u equal. Let's see. Oh no. This one's not a. It's not a. It's a substitution. Let u equal t minus 1, which means that du. Okay, I'll do it. Okay, y is the integral. Let me write it down. All right. Here you go. So, yeah, this is straight substitution. U is t minus 1. Sounds like we're getting ready to blast off. And then, let's see. That means that t is equal to u plus 1. You can do this in any substitution you do. You can always switch the things up like this. But anyway, du is dt. So y is the integral of, notice that for this, that substitution there, and for this one, I'm going to use this substitution here. So this becomes u plus 1 squared. So that's this thing going through here down to there. And then the square root, I'm using, and then du is dt. Okay, so we have u squared plus 2u plus 1 times u to the 1/2. Okay, so this becomes u to the 5/2, 2u to the 1/2. You can do this now, so I'm not going to. Now for the bonus material. Let's say you have something like this. You have two choices. You can either suffer through 5 integration by parts, which is what you're going to have to do. You're going to let u equal x to the 5th, du is equal to e to the 2x, and you're going to do 5. You're going to do it 5 times. You're going to have to, just like we had to do it 2 times with that other, wherever it ended. You're just going to have to do it a bunch of times. Or you can do this all at once using a table. So here's how the tables work. You have u, and you have dv. So what I do when I use tables is I start with u, whoops, x to the 5th, 2x. Now you just remember that you're going to repeatedly, because as I mentioned back here, let me pull this up here. With this one, that's the one I was referring to. If you ever have to do integration by parts twice, you always stick with the same function is u, and it was the e to the x part that was dv. Anyway, same thing goes here. You're going to be using integration by parts 5 times, and you're going to use the polynomial is going to be u, and the dv part each time is going to be e to the 2x. And so to do this quickly, you just do it. Watch this. I'll do it 5 times all in one shot. So x to the 5th, I'm going to have to differentiate this thing 5 times. So we just go down and derivative of x to the 5th is 5x to the 4th, and then you get 20x cubed, and then 60x squared, 120x, 120. Okay, I lied to you. We keep going until we get 0 in the u column. So I do one extra. So even though I only have to do it 5 times, 1, 2, 3, 4, 5, I go all the way till I get a 0. So these are all derivatives. And then over here, I'm going to do integrals. That's what you do with the dv part, is you integrate. So integral. And so let's see, the integral of e to the 2x is 1/2 e to the 2x. Be careful with these things because it's easy to mess them up. 1/4 e to the 2x, then 1/8 e to the 2x, 1/16 e to the 2x, 1/32, 1/64. Okay, now for the cool part. Let's see if we have. Sure. Now, what I've done here is that I have u and dv. But remember that when you're doing integration by parts, you're going to do u times v. And so this is dv for this level, for this u. So the v that would correspond with this u is down here. So the easy way to do this is just to draw diagonal lines through so that you have all of your u's and dv's matched up. Now there's one last thing they have to remember when you're doing this all in one, instead of doing it one at a time, is that when you do u times v, then you subtract the integral of v du. And so what's going to happen here is this thing is x to the 5th times 1/2 e to the 2x. But then the next one down is going to be subtracted because of that minus. So this one, what I'll do is I'll sometimes put pluses and minuses. I'm going to run into myself here. I'll do it in plus, minus, plus, minus. Okay, so let me write this all down. Then you can Wolfram alphabet to see that I am correct. I'm not going to bother because I know I'm correct. E to 2x, and then 20 over 8. Sorry, I'm combining these things. So you have 20 times 1/8. I probably should have simplified that. X cubed e to the 2x. Oh, I could factor out. And the next one's minus 60. Just make sure if any of these are minus in here, then that might have a double negative. So just be really careful. Let's see, so it's 60 over 16, x squared, e to the 2x, new line, plus 120 over 32, and you can see x e to the 2x, minus now 120 over 64, and there's no x there, it's just e to the 2x. So probably if you did this on Wolfram Alpha, it would certainly simplify all of the fractions, and it would probably factor out the e to the 2x. Don't forget the plus c, because it's an indefinite integral. All right, hope you enjoyed this mini lesson on integration by parts. Have a wonderful day.